The object's deallocation is not an atomic operation. The object doesn't either exist or not exist. Between being fully functional and accessible and disappearing from memory completely, there's up to 5 stages in the object's life cycle. Let's have a look at them. When the object has at least one strong reference pointing to it, it is considered live. This is the most common state for objects in Swift, and all the normal ARC rules apply to them. The Swift runtime will make sure the objects stay accessible as long as the count of strong references is above 0. When the last strong reference goes away, the object's deinit method is called, and the object itself transitions to the deinitting state. In this state, the object is no longer accessible for calls, but it can still have incoming weak or unknown references, and physically it still occupies some space in memory. In the dead state, the object is fully deallocated and using no memory. The site table is freed as well. But between deinitting and dead, the path may diverge, based on the presence or absence of weak and unknown pointers. Let's explore the most complex case, where the object has at least one reference of each kind. In that case, it goes through 2 intermediate states. When the deinit method completes, but the object has unknown and weak references, it becomes deinitted. Everything else stays the same. The object is still inaccessible to others, while still occupying some memory. It can still have incoming references, and because of that, it still keeps the site table around. When the unknown reference count reaches 0, the object's memory is finally freed. But surprisingly, it's not the end of the journey, because weak references may still exist. The object doesn't become dead, but instead transitions to the freed state. At this point, the object itself doesn't exist, but the site table does. Only when the last weak reference disappears, so does the site table. And then the object finally becomes dead. That is the object's life cycle. As you can see, using site tables allows the runtime to free memory more efficiently, instead of allowing objects to stay there for a long time. But you can also see that if you want even greater control over your app's memory, you need to be conscious about when you start and stop using references.